So this is it. This is what it's all about. This is the replacement for the microbit, or really it should be the replacement for the microbit. It's by the BBC. It's called the Doctor Who HiFive Inventor Coding Pack. So let's have a look what we've got inside. So we've got instructions. Now with the instructions, I can read out the specification for you. So HiFive Inventor, Internet of Things microcontroller. It's a 150 MHz FE310 RISC-V processor, 2.4 GHz radio and Wi-Fi. So one step up from the microbit there. 64K of RAM for data storage, SRAM, 512K of onboard flash memory for program storage, 6x8 RGB LED with 16 million colours, built-in accelerometer, compass, temperature, ambient light, and I know it does IR as well. High precision analog digital converters, edge connectors, expansion board by I2C, SPI, GPIO, UART, USB connection, 4.5V battery pack, and digital I/O pins. So let's have a look at the device. So this is it. Let's zoom in a little bit there. Okay, so this is it. It's got a standard edge connector. It's a nice little hand case. Says Doctor Who on the back. If I open the case and just pop the board out, there we go. Can we see that? Okay, so that's the board, and there is what we've all been waiting for. It's an ESP32 Wi-Fi chip. Let's see what else we've got inside the box. It's nicely packaged. It comes with a speaker. It's using, unlike the new microbit, it's not built on the board. Is that focusing in there? It's using its own speaker with crocodile clip connectors. It's quite good actually. It's quite high quality sound. We've also got battery pack, same connector as the microbit, but this is a 3AA battery pack, 4.5V, which is much better, and it will certainly support that larger screen with the, because these are near pixels directly on the screen, so it will support that larger screen as well. And we've also got a set of crocodile clips ready to go, and a USB cable. Nice short one, but I like the way it's got the LEDs built into it, so it flashes lovely. So let's go give it a go. This is the website. So we've got the option to buy it. In your pack there's a code that you can redeem for the lessons, and we can sign in. Got a little bit about the actual device itself. This website's not quite fully finished yet. It doesn't go live for a couple more weeks. Everything we need to know. Some information about the lessons. There's our pack. That's what we get with a device. And then some reviews at the bottom. Okay, so let's sign in. I've already redeemed my code. Let's see what lessons we get. Okay, so we start off with the Doctor Who Planet of Adventure. This is the block coding one. I'll just skip through a couple of the lessons and have a look.
Ooh, that's a smell. Ozone.
Okay, a few cut screens.
What the? Ah! First the TARDIS, and now this. It's not every day something can shop. It seems I'm not the first travellers. It looks like we've been in a room. Let's look for clues and see what I can salvage. At least there's no shortage of... Look at this! Human tech! But pretty advanced. If I code it right, I should be able to scan this planet.
Okay, so we've got, what have we got? 1, 2, 3, 4, 5, 6, 10 lessons using the block coding environment. 10 lessons using the MicroPython environment. Now you can see these are blue. I've gone through all of these lessons. They are quite interesting, quite good. We can create a blank project, so we can do a blank MicroPython project, but otherwise we have everything there. And let's have a look for create projects again, block project, so the usual block interface with the individual functionality, just as you expect from Tinker. And then the opportunity to save your work, and you've got projects page for past projects. So the usual high quality resource from Tinker, along with the usual super high quality resource from the BBC, is much better than what we got when the microbit first came out. One thing that puts this HiFive board head and shoulders above the microbit has to be the fact that it's internet enabled. You can go on the internet. So here's a as an example piece of code. So this piece of code, right, simple one. It's making a HTTP request to this website, this Notify website, and on this website, if I pop up this website, you can see what's in it. It's an API that allows you to get things like where the space station is and who's in space at the moment. So I've based this on some of the lessons. One of the lessons is about using weather data, and I've done exactly the same, and I'm printing to the screen so we can see it rather than displaying it on the board. But once I've deployed it, which I have done, and run it, okay, I'll actually restart it so we can see it run. It will give us that there are 3 people on the space station, and they are these 3 people here, and message said download completed. So I've connected to the internet with board, and I've downloaded some data. This is a similar project. Once again, I connect to the internet, same website, different request this time. I'm going to get the longitude and latitude back. At the moment I've got them displaying to the screen, but I could very quickly just change that to a print, so I don't need to display it on the screen, so then we can actually see what we're getting. And so I'm going to deploy that. And we can see this time we've got the latitude, longitude, timestamp, data from the website. And not only can this pull data from the internet, because it's an Internet of Things enabled device, it can also push data up to the internet as well. I've set up an account, with a free account, with this thing called ThinkSpeak, and I've got the API set in my program, and I've got I've followed the instructions from the same WeatherBot program and the instructions on the ThinkSpeak website, and I've deployed this. So if we restart the HiFive, we'll see got my connection, and I'm pulling in data, and I'm updating the data every, what's that, about 5 or 10 seconds, 5 seconds. Okay, so this is being transmitted up to the website every 5 seconds. Let's have a look at this as visualised data. So I've got the temperature's not changing a great deal. I'm not getting very warm, but we can see with me moving it, I'm getting some change on the seismic. My light sensor is now in the daylight. I'll hide it away. Turn the heater on. Let's try and crank some heat up. Let's see if we get a change in temperature. Looks like there's something not quite right with my temperature readings there. It seems to have spiked. but that will purely be me fiddling about with it. What we got now, that looks more realistic. Not quite sure what went on there. Heat it up now. Light pollution's dark, let's get it in the daylight again. So that's pretty cool. We've got a device connected to the internet, pulling in data from its internal sensors, and don't forget you've got external sensors that you can add to it through I2C or SPI. Data, recording the data just in an array like the website says, and that data is being pulled into this website, giving us live data. I think that's absolutely awesome.